You'd think the biggest ideas in the universe would start with a bang, right? But sometimes they start with a yawn. And that's exactly what we're diving into today. This absolutely wild story of how a boring moment in a lecture hall might just rewrite everything we think we know about physics.
And that's really the core idea here, isn't it? That these massive, revolutionary insights, they're not always found in some high-tech lab. Sometimes they're hiding right in front of us, in plain sight, just waiting for someone to actually look.
So, let's set the scene. It's 1971. Just picture it. One of those stuffy old lecture halls. You've got the low hum of a projector and a topic, oh man, a topic so dense it's practically a black hole for attention. This is seriously the last place on Earth you'd expect a universe-shattering discovery to happen.
Right, so we're talking about a lecture on something called Yawn decay. Basically, it's when these tiny subatomic particles fall apart. I mean, it's a super niche topic, even for physicists. The professor, Milton Ash, he was just trying to explain this one little unsolved number in his data. But what he didn't know was that his data was hiding a secret way bigger than anyone in that room could have possibly imagined.
But see, while pretty much everyone else was probably daydreaming or doodling, one postdoc, Ella Rivas, was paying attention. She was locked in. And that's when she saw it. This tiny, confusing little wiggle in the data. An anomaly, something that just didn't quite fit the standard model. The official rulebook for particle physics. It was so small you could blink and miss it.
And this is one of those moments, right? A real fork in the road for a scientist. Do you just write it off? Say, it's just experimental noise, a glitch. Or do you get curious and ask a much bigger question? Voss chose curiosity. She started to wonder, what if that wiggle wasn't noise at all? What if it was a signal, a perfect hidden reflection of something else?
And just like that, from this tiny little observation, a totally radical new vision of reality began to take shape. This is that classic moment where one small question starts to snowball into these absolutely colossal answers.
Okay, so to really get how she made this incredible leap, we need to talk about something called the CPT theorem. It's a huge deal in physics, a real cornerstone. The gist is that the universe has this deep, fundamental symmetry. The laws of physics should still work even if you flip a particle's charge, its parity, which is like its spatial orientation, and even the direction of time itself.
So with that in mind, Voss connected the dots. It was a total aha moment. She realized her weird data, that wiggle, it perfectly matched a mathematical possibility that the CPT theorem allows for, a mirroring solution. And the implication of that? Whoa. It suggested that our entire universe might have a twin, a perfect mirror reflection.
So there she is with this incredible, totally mind-bending hypothesis. But, as any scientist will tell you, having the big idea, that's the easy part. The hard part is getting everyone else to believe you.
And yeah, it didn't go well. Even though her mirroring solution was a perfect fit for the data, the scientific community just shut it down. The main problem was, back then, the technology to actually test for a mirror universe just didn't exist. So her idea got labeled speculative, untestable, and was basically put on a shelf to gather dust.
But here's the thing about really great ideas. They don't just disappear. For decades, this whole mirror universe thing was a fringe concept, something people talked about but didn't take seriously. But then, slowly but surely, things started to change.
I mean, this idea had a really long road. It starts with that first observation back in '71, gets dismissed almost immediately, and then it's basically radio silence until the 1990s. That's when new experiments at places like CERN started getting these little hints, whispers in the data, that maybe, just maybe, Voss was onto something huge. And now, fast forward to today, and the search is back on. Big time. Yeah, these new, super precise experiments started churning out results that just flat out invalidated the old reasons for dismissing her theory. And all of a sudden, the mirror universe wasn't some wacky speculative idea anymore. Nope, it was a serious contender, something that demanded a real investigation. And that brings us right up to the present day. Right now, physicists are actively designing brand new experiments specifically to hunt for this hidden reality. Think about that. An idea born from a boring lecture in 1971 is now on the absolute cutting edge of physics. So you gotta ask, right? Why now? Why is this decades-old idea suddenly so important? Well, it turns out that our universe has a massive, glaring mystery, a huge problem.
And the mirror universe might be the key to solving it.
Okay, get ready for this because it's pretty wild. Everything we can see, everything we can touch, you, me, the planets, all the stars and galaxies, all of that is only about 5% of the entire universe. 5%. The rest of it, this enormous chunk of reality, is made of dark matter and dark energy. We can tell it's there, we see its effects, but we have absolutely no clue what it actually is. And this is where Wallace's old idea comes roaring back, with this beautiful, elegant, and totally mind-blowing proposal. What if dark matter isn't some crazy, exotic new kind of particle we have to hunt for? What if it's just the regular matter from that mirror universe? It's invisible to us, sure, but it's still there, and its gravity is reaching across that veil, shaping our own universe. And the implications of this are just staggering. I mean, not only could it solve the whole dark matter mystery, but it might also explain why time seems to only move forward, the so-called arrow of time. It would prove that there's this vast, unseen reality coexisting with ours. And maybe the best part? Scientists are now coming up with these really clever, cost-effective experiments to finally actually test for it. So when you step back from all the mind-bending physics, there's a really profound human lesson in Ella Rivas' story. It's about more than just particles. It's about how science, and maybe even life itself, actually works.
It really shows us that progress isn't this neat, straight line we imagine. It's messy. And as the source material points out so well, scientific discovery is often completely unpredictable. It can be sparked by just one single moment of pure, focused attention in a room full of distraction.
And that kind of leaves us with a final question to chew on, doesn't it? The next time you're in a boring lecture or a meeting, or just find your mind starting to wander, maybe think about Ella Rivas and that little wiggle in the data. What secret is hiding in plain sight, just waiting for you to notice?